Okay, friends, let's try a couple more here. If I'm traveling down Archie Briggs Road at 36 miles per hour, which I know is speeding, but when I'm on my bike riding home, it's really fun to go that fast. How many feet am I going every second? Okay, so what's interesting about this, I want to know how many feet I'm going every second. That's feet per second. That means what I need is itself a rate. It's not just a single unit like feet. It's feet per second. But again, this is okay. It's okay to have units in the numerator and denominator. It just means that we're going to have 2 units over here, numerator and denominator. And let's just take a quick look. I think we do. Yeah, 36 miles per hour, what I just said. So we have the fact that I'm going 36 miles per 1 hour. Now, we had a similar situation in the last set of problems, in the Dory problems, in that there was a denominator, I think, 1 mile. And here, it's 1 hour. But what's different here is that we're going to have to change the 1 hour into seconds. So, we're going to have to do that while we're also changing miles into feet. Which is not that big of a deal, honestly. So let's pick. We have to do one of those first. We have to either change hours into seconds or miles into feet. I need a coin to flip. I can't decide this. I'll flip this thing. Heads. Here's the Captain Mike Nalgene. Heads, we do the miles to feet first. Tails, we do the other one. Okay, it's heads. Miles to feet first. Okay. So we got miles up here. We need feet. We need a conversion between miles and feet. Now, in case you don't know it, and it's okay if you don't, you will eventually in this class, there are 5,280 feet in a mile. I heard somebody just say why. I don't know. I'm sure there's a reason somewhere. It's not the metric system. I really don't care. I don't really care about why things are the way they are in the imperial system. The metric system, I've already complained too much about it. I'm going to stop. Okay, so what's great about that is we now have miles going. Feet are where they need to be, good to go. Now we got to deal with the time, the hours. So I've got an hour down here. That means I'm going to have an hour up here. And I'm realizing right now I'm going to run out of space. So I'm going to bump this over a little bit. Feet per second. And with your permission, I'm actually going to simplify it in FT over SEC for feet per second, if that's okay with y'all. And since you're not there to answer me, I'm going to assume you said yes. I'm going to put that over 1. Hours. Well, do you know how many seconds are in an hour? I know how many minutes are in an hour. I know that there are 60 minutes in 1 hour. Which means I can now divide off that hour and this hour over here. It's okay, and break my chalk. It's okay that the hours aren't in the fraction directly next to this one. They're all multiplied together, so at the end of the day, we've been doing that all day, just multiplying them all into one big chunk. We're almost there. We're at minutes, we just need seconds, and I think we got it. 61 minute is 60 seconds. Yeah, that's good. That's good. So now we've got, actually, this might be a good place to erase the units that we don't have anymore. Don't have miles, don't have hours, do have feet, don't have miles, don't have minutes. I should have divided those up too. Okay, that hour's gone, those minutes are gone. So that's all that's left. And look, you can see the units that are left. Feet per second. This is awesome. So it's 36 times 5,280 over 60 times 60. All right, what's that equal to? That tells us how many feet every second I'm going. So 36 times 5,280 divided by 60 times 60. I am going about 53 feet a second. Wow! Holy crap. Louise. It's nuts to think about. Every second you're going about 50 feet. That's fast. That's fast. And I think this is why we get ourselves in trouble when we drive. Because cars generally go much faster than bikes. Archie Briggs, the speed limit is actually 30, so I'm speeding going 36. But I get passed routinely on that road going 36, so cars are going even faster. But yeah, it's crazy how fast vehicles are going when they're rolling along at, 30, 40, 50 miles an hour. Okay. Next one is, suppose I average 18 miles per hour riding home. How long will it take me to ride home, which is 6 miles away from work? Okay. Let's clear this board again. So, how long will it take me to ride home? So I want to know how much time it's going to take me, and I've got some time in the unit of 18 miles per hour. So I'm gonna just leave it in hours for right now. How many hours is it going to take me to get home? Okay. You know what? I'm going to start with that 18 miles an hour. I'm going to start with that 18 miles an hour, and here's why. I've already got the hours in it, but I don't want to write it. I'm going to write it like this, but I'm going to erase it. I don't want to write it as 18 miles per 1 hour. Because look at where hours is. Hours is up top there. It can't be in the bottom down here. So it's got to be 1 hour every 18 miles. So now I'm stoked because I got hours in the right place. Yes, that's good. But I don't want miles. Miles has to go. So that means I have to multiply to get rid of that miles. And I also don't want a denominator in there. So then you check the problem and you say, well, did he tell me how far? And I did. 6 miles away. 6 miles away. The miles are going to divide off. Hey, some of you might be thinking, could I have just written these this way? Yes, absolutely. It'll work that way too. The multiplication has what's called commutativity. I think it's a French word that means you can switch them and nothing changes. And then you just got hours. So it's 6 over 18, which is 1/3 of an hour. If you prefer decimals, that's 0.33. 3. So it's 1/3 of an hour. And the last question down there is how many minutes is that? And I think you can do this without having to go through all this. 1/3 of an hour is 20 minutes. All right, my friends, you are now ready to do your Am I Gonna Die in This Room lab and the follow-up homework for it. Go get them.